Today we have with us Mike, who is a literal rocket scientist, and he's going to tell us how making influences decisions. Welcome, Mike. Please tell us a little bit about yourself.
My name is Mike. I work for NASA's Jet Propulsion laboratory. I'm a mechanical engineer by trade. My current role now is a supervisor for inspection in the electronic fabrication house at JPL.
I'd love for you to explain some of those details. How did you become an engineer? How does your skill set as a mechanical engineer help you in your work?
I guess it all really started back in high school. As a senior, I was in AP Calculus, which is kind of wild for me to say. I enjoyed it a lot, and I did very well.
Nice.
And so that was kind of my trajectory into kind of the science and engineering world.
You kind of said it like you were a little bit surprised that you liked AP Calculus. But is that true?
I would say math in general. Going back to junior high, I was not the best student. I remember struggling in math and having some very unhappy parents about it. Being the good parents that they were, they made sure that grades were number one, and some of the things that I enjoyed doing were going to be taken away if my grades didn't get right. It was 8th grade. I still remember the teacher's name. I would stay after class. He would continue to tutor me, and then that was kind of my aha moment in trigonometry at the time, where I started looking at math like it's just another language. I'm just learning a language.
Right.
The equations just mean something in math, speak. And so that was kind of what propelled me going into high school, continuing with math. I played football, so I was in drama, so I kind of feel like I'm this kind of outlier within what is stereotypical for a student. And then here I am, a senior, varsity football, and taking calculus and getting a 4-point shape kind of who I am today.
I'm imagining that you had lots of different kind of peer groups.
Yeah.
And a lot of those peer groups did not overlap. You were like one of the connecting people in these two very disparate peer groups.
I can hang out with, the nerdy guys. I probably resonated more with them. Studied with them. I was in the kind of the accelerated classes with them. But yet I was also this jock, and I was accepted by that crowd as an athlete, but those groups wouldn't intermix. And it in the position that I'm at today, in the way that I communicate, in the way I can easily kind of get an idea from whatever ethnicity, whatever group, whatever social, it's like I can completely click and relate.
So those two groups,
the
ability to talk to that diverse set, you think that's like a thing, a muscle memory that you brought to this job as well?
1,000%.
Wow.
1,000. So one of my strengths right now working for NASA is my ability to communicate the geniuses are coming up in their next missions, and taking that information and putting it into a conversation of how it translates. And this goes all the way down to the folks that are putting things that were dreamed up into physical,
in
matter,
physical shapes.
And that's an important piece to a successful mission, because you can't just have people dream it up, because they're not going to be the ones putting it together. There's a different skill set related to it's art, and I use that word a lot actually when I describe the technicians do. They are artists. They're truly brilliant artists.
Thank you for bringing that word up in relation to technicians, because that is definitely a concept that on the podcast we've heard a lot of our artist makers mention, because even if they have a technical background, they talk about the art of making.
Yes.
And how the technical background and the art of making have become seamless for them. In your case, what you describe in your job, you sort of know what the line is, because you are still talking to two different groups.
Yeah.
So you're taking information from one group and translating for the other. Tell us about what influenced your choice. I mean, to become a mechanical engineer.
I would say the turning point, and I do have that moment of I'm going to be an engineer. I went to UC Riverside for undergrad. I actually went in undecided, And so I'm at UC Riverside, and I remember having a conversation with a friend who was at the time probably like a junior. And I was like, I don't know what I'm going to do. And he was an engineer at the time. Hey, Mike, look, take this physics course. It's like Intro to Physics. See if you like it. The class was taught literally by the chancellor of the school. And I thought, it's decent advice. I'll give it a shot. A lot of self-doubt at that age, right? I probably won't do well. I probably won't like it. It's fine. I'll get it. I'll have an exit. I took the physics course, heavily math-based, applied science. So now it's like I get these numbers. Physically, there is a right answer. There is no doubt when it comes to like, if I drop this weight, how hard is it gonna hit the ground? Like all that is like you can calculate the flow of water at this rate, and you got these angles. What's the flow of water at the very end? Like there's only one right answer. And so when I took the class, and I started having these like, oh wow, like math actually, it's fun. You get answers, and it's all around us. I did very well in it, and so that was a moment that I knew after I took the course and I passed it that I was going to be an engineer. And I went in, and I already had like credits because of AP Calculus. So they're like, you look good, and just take a few more requirements, and we'll get you transferred into mechanical engineering. The rest is history, as they say.
The way you describe that really sounds so close to how maker artists talk about this. The way you described it was very kind of visual. It's almost like you were thinking about how it's being applied to everyday things or objects. And that is such a critical skill set. And I should teach in the School of Design, and this is something we used to instruct students on, how to visualize the final piece. Because in a lot of cases, once you can visualize it, then sketching it out or designing it in CAD, all of that becomes really important.
Yes.
So it sounds like unknowingly or knowingly, you've sort of stumbled upon that pathway. Do you think like the next steps in your mechanical engineering either enhance that or added to it somehow? Maybe the classes that you took or the experiences that you had?
I would say definitely enhanced it. As I look back, I just remember thinking, college is really about networking, right? You're taking these courses, you're taking classes. I felt like a lot of the classes I would never use again. If we're just taking this curriculum, a lot of the stuff makes sense. The labs are very good because, again, going to your point, you have this project, and the idea is you make a robot, and it's all model based. But like, you need to make a robot, and it's got to be able to hit this tennis ball at this rate, and it's got to be able to receive. And so you dream up what is it going to look like. You're going to have trial and error. And then you're going to tweak it. You're going to tweak it. It's going to get better until you get to like a final product.
I'm seeing definitely a theme in the guests that I had on the podcast. A lot of them talk about how they learn processes and concepts in school, in college, at work, which they were not able to understand what application that concept might have. But the minute they went to making, it's almost like the muscle memory, and suddenly it's like they have a superpower that nobody else has. Tell us a little bit more about your journey in the sense that once you graduated, what happened next?
After I became an engineer, and then within 2 months out of getting hired at the small kind of mom and pop aerospace company, landed a job at Northrop. Yeah.
So are there any experiences there that let you apply your conceptual learning?
I was a manufacturing engineer for large structures. That's dealing with a lot of people, and again, it's you're the communicator. As a manufacturing engineer, you're taking these designs from design engineers. You got to translate that into work instructions for the technicians to put together. And then my first kind of moment of like in the big leagues, I wanted to try design engineering, did that for a couple of years. Didn't quite like it because it's a lot of like you're behind the computer. You start learning more about yourself. I remember this experience that I had as a manufacturing engineer with the technicians. Loved being around people. So after a few years being a design engineer, which the experience was great, went back to the manufacturing world. And that's where I really found my stride. It's a communication. It's if there's an issue, if there's a problem, how do you troubleshoot it? And some of those lessons that I learned in college, it's if you don't know, you got to network. Who has the answers, right? And then you go find and you start building these relationships, and you start realizing very quickly who has the answer for a very unique problem that you have, and then you start kind of spitballing ideas. Well, would we be able to rework this? Like literally, like if I had a part that has a damaged lead, let's say the lead was severed off, it's like soldered to the board. You have some options. Can we rework it? Oh, maybe I could solder the missing lead back together or the broken lead back together. It's still the same part. Or do we remove and replace it? That's another option. Or do we repair it? Maybe I take the hole, I cut the lead off, and then I take a wire and I solder it down back to the board. The functionality, it still works. But there's a lot of things that can go wrong. It could be, hey, this part it takes 2 years to make. We don't have time. We're launching in a month. Well, that's a problem. Let's go into our bag now and get really creative as engineers. How can we repair it? And not only repair it, we got to prove that it's going to survive space, right? And so now we got to test the heck out of this. All that I'm talking about, college really kind of beats you up in these labs, in these classes, like the art of iteration, the art of pushing and never giving up.
When you're faced with a problem like this and you have multiple solutions, there's no precise way to do it, right? Like
no. And until you get in there, you start realizing all the possibilities that can go wrong. And so to your point, like you might have the right part, but maybe it costs 10x of the one that you wanted. Do you want to really spend 10x? Is it really worth it?
Yeah.
Can you wait for the manufacturer to deliver it to you? Well, that might be a year. Schedule is a big part of it. Budget's a big part of it. And so it gets very complicated, very messy. And then you have people who are in their lanes. Engineers we just want to fix.
Right.
Then we have the business folks that are like, no, it costs too much. Then we have the project folks that are like, cost and schedule, like just get it out. And then we have quality assurance that's in there, like pump the brakes. We got to make sure it's reliable. We got to make sure it's functional. We got to test it. I want to see the data before I give you and so all these different stakeholders have a say.
Yeah.
And it's all about connections. It's all about communication, and making sure you really make good points, because you don't want to do something that's going to bite you in the end just because somebody had the loudest voice in the room.
Yeah. It's obvious that every time you encounter a problem situation that you've got to address, there are not only multiple solutions, but there's multiple stakeholders and that you have to account for. So how do you visualize all of them?
Yeah.
Each answer is kind of like the start of the rabbit hole. How do you keep track of all of this?
Yeah, you're giving me PTSD. This is very normal kind of, yeah. Well, first it's I'll say trades. Trades is a big one. So we'll assign somebody as a lead, the form a team of all the stakeholders, so everyone. And that to me is key, having the right people in the room, because they're going to be looking specifically for their area if there's any holes they can poke in. If you don't have them all in there, and say you have half the team, everyone might be like, this is a great plan, but then somebody who's not there is gonna have an issue later as they're building it and it didn't fit. I didn't have the right tools. So that's number one. Kind of build your team, and then you do your trades. You start going through the different scenarios. You got to keep track of everything. You got to keep it in a spreadsheet. I typically like to do it just kind of PowerPoint form. Here's trade one. Here's all the scenarios I can play. Here's the cost. Here's the schedule related to this. Scenario two, same thing. Here's the cost, but it's more reliable. It's going to take longer. Can you take the hit? Or more expensive? Can you take the hit? And then collectively as a group, we come to a consensus. But it takes time, and a lot of times you don't have the time. Because you're building one-offs, and design typically takes up all our schedule in the beginning, and then once it gets into fabrication, we're already behind schedule. So now it's like we got to work weekends, very stressful. And then it's somebody might say, you know what, we'll test in parallel. Go ahead, because that's just the best we got. We don't have the time to wait, and so we'll build it. Everything looks good. We'll build like a mock, a number two, a control that we're going to test, and it's got to be exactly the same material, parts to the whatever repair we're going to do. They'll test the heck out of it, and then somewhere down the line, go, hey, it passed, so go ahead and fly it. But it can get very hairy very quickly. I would say right now a lot of what comes to mind is, so I'm in the quality assurance kind of world right now, and so we have these requirements that we're trying to hold the line to. Like a certain part needs to show a certain workmanship standard. And a lot of what we see are engineering kind of looking at like, why are you writing that up? It's not an issue, but it's completely two different hats. And so if it feels like if it's up to them, they would want no quality. It's like but you don't understand until you put on that quality assurance hat, like the importance of why they're there. And why there's certain gates that are involved with holding the line if they need to. And so a lot of what comes to mind is just a lot of conversations of like, you can't just blow past this gate saying I'll write a waiver. Like, this is an important institutional requirement for these reasons. Let me show you the data that would suggest like this would be mission failure if we didn't do it. Because again, a lot of it is just schedule driven. They just want to kind of blow through some of the gates.
Everything you do has to go up in space. And I think that's kind of also like a really big deal, because with other stuff, like, I get the example of my car. It's just right here. It's not that big of a deal. I can just go to a mechanic somewhere and get something fixed.
That's right.
Fairly quickly. But once it's out there in space, clearly you can't just go to a mechanic to fix it.
No.
I have some background in QA. The physical products, nothing, not to the engineering level that you have. But I'm trying to think back to my own experiences where I tell somebody, hey, this shirt button's not on right way, and they're like, it's a button, what do you care? It is. That is true. It was a little bit of conflict sometimes, right? Because you're then starting to evaluate, well, should we really enforce this standard? It's a shirt button. So, but I think in your case, that enforcement agenda is so much more critical.
Yes.
Because it's going into space.
When you mentioned the whole button thing, and it's not a big deal. In our world, we call it's a risk. It's a risk, right? And we do use that. We do assess things like that. But there's also this line that as you start letting things pass, the goalposts move. Right. And so that's also something that we're very aware of. And we try to bring it back. We just try to hold it to maintain, like, this is our baseline. I would say our secret sauce when it comes to JPL as a whole is when it is a mission critical item. We got something on the launch pad. We had some box or some electronic that failed. We just caught it luckily at the last second. JPL will go above and beyond to remake whatever it is in record time. And those are the times where we'll look at things and really just say, yeah, that's low risk. The line, there is no line.
Right.
Do what you have to do, work your OT, Saturdays and Sundays. But that, like, few and far between. Don't say, hey, just because we got this in a week, I expect everything to be done in a week. No, it's like people get burnt out.
Right.
But we know we got to do what we have to do when the going gets tough and we get things done. It's pretty incredible to see.
This is definitely a very kind of unique, I think, skill set that you acquired. Do you think your the way you think in your job, about problem solving and quality control, does that translate over? Is there anything in your everyday life that translates into your work?
I don't realize it. I have an engineering mind, and I kind of look at things and I quickly assess what's the problem, how can I resolve it. But I'll give you an example. So I love coaching. I coach. I have 3 kids, and I communicate in these message apps. And last year, multiple parents would come to me and be like, "Oh my God, I love your messages." I said, "Love my messages? What are you talking about? You have pictures, you have bullet points. Like, I'm just getting information out there." And then they started calling me, "Oh, JPL Mike." And then I had to like take a step back, look at the messages, and then it hit me. I am literally writing my messages like I would write work instructions at work for my technicians, highlighted in bold, practice days.
Right.
And bullet this, bring that, bring this. Game day, game, bullet point time. So now you're seeing just a header, what the context is going to be in there, whether it's game practices, and moving forward, what the kids' party is going to look like. For games, I put pictures in there. Make sure you wear this color combination. Here's a location of the away game. I'm literally writing work instructions for my team, and they appreciate it.
But again, I've got to remind everybody every time, everything he does goes into space. So the high standard,
I'm like,
that's your baseline standard is an extremely high standard.
I guess so. I guess I probably come across as like this control freak. Yeah. I'm like, okay, I got to tone it down now, I guess.
No, but that's a great example because I'm a parent too, and some of the messaging I've been in these type of situations. I'm like, I'm trying to visualize what
I'm
do you
confused.
say?
Yeah, I'm confused.
Yeah, I don't know, and especially for me specifically because I didn't even go to school in here, so there's a lot of like
slang,
cultural nuances. I have no clue.
Yeah.
Thankfully, I Google it or YouTube it sometimes, but I'd love to have somebody like you give us those instructions because it would really help. You're the outlier, like being in the calculus and the football group. Like those are not common. There's a stereotype for one or the other.
And in drama,
in drama,
on a stage.
Yeah, those are not. You're not a typical like stereotype, right?
Right.
So there must be something that in your personal life influenced that.
Right away I go to my parents.
Okay.
I'm first generation. They were born in Mexico. They immigrated here, and I reflected on this actually really recently in just, oh my God, like the life that they chose to give their kids, myself, a better life. Not having high school degrees, not knowing English.
Wow.
Like as I go through that list, as I was reflecting, like the odds were absolutely stacked against me and my brother and my sister to not succeed. But here I am as a kid, not realizing the struggles that my parents went. And I can say this in so many different ways, but like they just so happened to pick a city here in SoCal, because it could have been anywhere in the States, right? And in the neighborhood that I grew up in, where I was like Stranger Things. If you've seen that show, where there's just kids all the same age, I was telling my brother, like, that's about us. Like we were all out unsupervised. There was like 10 kids in our neighborhood, all the same age.
Wow.
Parents got along. Like I really feel like that shaped who I was, just being super open and free, exploring the world when the world is just this little bubble of a neighborhood. And then as I go through, and it was always my dad pushing, you are going to go to college. And so I thought that was just a normal mentality to have, and I always had that in the back of my mind. But being first generation and actually getting into college is a different story, because I had no one to show me the ways. There was the generational kind of families here that said, hey, take these courses, take this mock SAT, right? And you can literally game it to where it's like, oh, you're so prepped and you pretty much know how the test, and you can get this high score and go to this amazing college. Like those are the things that I think, it would have been nice, but then on the flip side, I had to learn it on my own, right? I had my brother, I guess, that kind of showed me, but that still wasn't enough. I'm kind of a trailblazer. You got to figure things out here. My parents weren't helping me, the English barrier. And so it made me a fighter, And the other thing that I reflected on is I had one of the best role models ever in my father, in his relentless work ethic, in doing what he had to do, getting up job after job. It was pretty amazing. And so indirectly seeing that, not really, I thought I wasn't paying attention, but I'm getting programmed. Like, you go and get stuff, you got to get up and move.
What kind of work did he do?
He was a journeyman engineer. He would take, when he came here, he took a welding course. He took, whatever it is somebody said they needed, electrical course. Then he started doing like handyman work. And he started working for different companies as like a building facilitator or something like
Right,
that.
right.
And eventually he got licensed, and he was like an engineer, like a backdoor engineer through work experience. And then he ended his career working for Univision in Culver City as like the house engineer. If something goes wrong, he'd go and fix it.
Wow.
It's pretty incredible. Like his
Yeah.
journey, his story. And so now being older with kids, I can't say thank you enough to him. What the work ethic he kind of taught me indirectly, and to never give up. So I would say he's my biggest influence.
Wow, that sounds amazing.
He's a Forrest Gump. I look back and I'm like, Dad, you're incredible. And I was underappreciated. I was still that bratty kid that just complained I didn't get enough. When I think about my mom, I just think about like, how does she do it? 3 kids in a generation without iPads. And so she was our anchor. She was taking us everywhere. Like I still like, I lose my breath thinking about like, how did she take me to soccer practice? How did she pick me up from high school? And my brother and my sister. Like, we were blessed. Like, we were in all sports. And somehow we managed to get there on time. And oh, by the way, we weren't by any stretch of the imagination, well. And so she was very loving, and she was just there. And I think that was what she gave the family. Lesson learned early on, if I'm in a meeting to this day and they say, hey, we want to make this change, what do you think? And it sounds good, even if it's a slam dunk, I'll say, I gotta bring it to my team, and I'll stress it to everyone else, like, bring this to your teams, get them in there,
Yeah.
let them vet it. In fact, they'll appreciate feeling like they're being a part of a decision.
Looking at it from the outside, these guys they just know what they're doing because they're already geniuses. But I really love how you're able to explain that even with such high precision objects or highly engineered designs, there's so much human debate around it.
Yeah.
When people think they want to become go into JPL or NASA or aerospace, they mostly only think engineering. And there's a lot of soft skills, and certainly from your experience, you've explained very well that how you communicate is critical.
Yeah.
So what advice would you give to somebody who's aspiring to a job role now in this industry?
And I would say right now is, we're looking for people who are team players. We're looking for people who are great communicators. We're looking for people who actually will, the phrase is talk truth to power. Somebody who's in an authoritative position might say something, and are you comfortable saying, I don't agree with it, but can you say it in a way that doesn't feel offensive, and not just to the authoritative figure, to your peers? And as I've been in this position, I feel like that's hard to find. Mm-hmm. There's very strong-minded people. There's brilliant people that don't like to be told their ideas might not be that great, or it needs some changing. I've worked with some amazing project leaders that are just very calm and elegant, and I'm fascinated by them because they're in a very high-stress situation, but they're able to diffuse tension in a room just by the way they're talking, probing, asking a question without making anyone feel uncomfortable or that they made a dumb decision. And those are the ones that I'm just like, I want to learn more from you, because I think that's a trait what's being sought after. And so what I would say is, for aspiring aerospace engineers is work on soft skills. Be comfortable in public speaking. There's Toastmasters out there, for those that don't know, and it's just this kind of club. You get together and it's like pull a topic out of a hat and kind of do a sales pitch, or if you have something you want to speak. But you're just practicing basically speaking in public. And I did that for several years because that was an area that I realized like I want to get better, because I was scared. One of the interview questions that I like, and if I'm helping somebody with like resume review or for an interview, I tell them like, hey, did you work in service industry? Well, what do you mean? Did you work in McDonald's? Did you work at like a TJ Maxx, in a department store? Put that on the resume. Like, this is like coming out of college, like just showing but it's not engineering. No. You know what it shows me and why I like seeing it? It shows me you've dealt with the crazy. You've dealt with difficult people, customers, and you've seen that world. And not to say that like that's the world of aerospace, but you're gonna have tough conversations. You're gonna have to work with difficult people. We come from all walks of life, and and we think we have it all figured out, but we don't. Like that's like
right.
There's so many battles, and that's one battle is, oh my God, I got to talk to this person again. But you can diffuse the situation, you can build rapport, conversation goes way better, smooth.
Actually, that's a great example. An engineer working, where you accept returns.
Yeah.
Because
that should be a requirement. I'm going to make that before I hire
right?
somebody. Like, okay, now your first job is working at Target.
Returns.
Yeah,
but returns.
Returns only.
That's
a tough spot.
Yeah,
that's right. And then it makes you tolerate it, not in the sense that's like you're dismissive, but like it makes your skin thicker, and you can walk away from that job and then let it go. Yeah. And not carry it with you back to your home or your family. Well, yeah, and so that's also an area where I've really improved to just kind of leave the work at work.
Okay. The last question for this session would be more about how do you think your skill set has evolved to what you imagined it to be and what it is now? Do you think how this field is going to be, where somebody has to have more of that balance of soft skills versus technical skills?
If I had to make a decision right now, I would say yes. I think the desire, if a hiring manager had it, would be I want somebody who's technical and also has the soft skills. For me, I never thought in a million years that my personality was going to be what kind of got me to my position. I remember being hired, when I got hired as this manager. And by the way, I thought managers were like pound your fist on the table, get things done type of personalities, and I was like, I'm never gonna be a manager. Until I started seeing this organization and the section manager, and I'm like, oh my God, he cares about people. He's just like me. I'm like, oh, I think I can be this manager. So I became the manager. But I remember when I got hired, one of the persons in the interview, who I got interviewed by, who I would be managing, and he goes, hey, I told them I wanted you because you would say good morning to me. I worked with them as an engineer. It's like, what? Wow. He goes, you would say good morning to me, and I don't think the other person would. But that stuck with me. It's like, saying good morning to somebody, was that a game changer?
Hey, Mike, I want to thank you for being a guest on the podcast. Thank you so much for sharing your personal and professional journey and your insights on how somebody could become an engineer in JPL NASA.
Thank you so much for having me. It was a blast.
Thank you.